today we're going over perpendiculars and bisectors. So we've already learned what perpendicular means, and we already learned what bisectors are. But what we're going to do is we're going to see what those do to our triangles. So we are going to look at some properties that perpendicular bisectors make. We're going to look at some relationships between perpendicular lines and bisector lines, and those relationships with triangles. And then there are going to be some points of concurrency, which means where they come together in a triangle that we're going to have to be able to identify and draw. So our first theorem says that any point that is on a perpendicular bisector, that only happens if it's equidistant from the two endpoints. So here we have two endpoints, endpoint A and endpoint B. And here we have a perpendicular bisector at point D. If we have a point on this perpendicular bisector, that means, like for example, point C here, in order for it to be on a perpendicular bisector, it has to be equidistant from A and B. So no matter what, any point on that perpendicular bisector is going to be equidistant from A and B. Our next theorem is called the Circumcenter theorem, and that is where the perpendicular bisectors of the sides of any triangle are concurrent, and that's called the circumcenter. Okay, so the point where if you make perpendicular bisectors on all three sides, the point that they come together is called the circumcenter. So here's a triangle, and if we wanted to make a circumcenter, what we would have to do is we'd have to draw a perpendicular bisector for each side. So here's our first perpendicular bisector. Here's our second perpendicular bisector, and here's our third perpendicular bisector. So this point right here is what we call the circumcenter. To get the circumcenter, we had to draw three perpendicular bisectors. So point P would be our circumcenter. All right. Our next theorem is called the incenter. So we had the circumcenter, which was where we made perpendicular bisectors. The incenter is the point that we get when we make angle bisectors of the angles of a triangle. So perpendicular bisectors when we bisect the lines, and then the incenter is when we're going to bisect the angles. So here's a triangle, and to create an incenter, we had to bisect that angle, which means those angles that are formed are going to be congruent. We bisect this angle, and then of course we bisect that angle. And so this point that we end up with, point D, is called our incenter. Okay, and so before we learned our next two relationships, we need to come up with some definitions. Our first definition is called an altitude. An altitude is going to be a segment that goes from the vertex of a triangle and is perpendicular to the opposite side. So before, when we were making perpendicular bisectors, those perpendicular bisectors, they didn't have to go through a line. In fact, we were bisecting that segment. But if we make an altitude, we start at the angle and we're going to go to the opposite side, but we're going to make it so that when we connect the angle and the opposite side, it creates a 90-degree angle. So it's gonna be a perpendicular line. Then we have what's called a median, and a median connects the angle to the midpoint of the opposite side. So it doesn't necessarily have to be a 90-degree angle, it just has to go from the angle to the opposite side. Okay, so let's demonstrate. An altitude goes from an angle, so you start at the angle, but then when you connect to the other side, you want to connect it so that it makes a 90-degree angle. That's an altitude. Versus a median, you're going to go from the angle, but instead of going straight down to making 90 degrees, you want to actually connect to the midpoint of that segment. So that's a median. Okay, and so when you do that, of course, since you're going to the midpoint, these distances have to be equal. Okay, so now that we have those definitions under our belt, our next theorem is called the orthocenter. So the orthocenter is the point that you get when you make altitudes on all three sides. So remember, the altitude is the one where you connect the vertex to the opposite side with a 90-degree perpendicular, right? So if you do that for all three sides, you get the orthocenter. So here's an example of the orthocenter. So you go from the angle and you make it a perpendicular, and then you go from your next angle and make a perpendicular, and then you'll do angle C and you'll connect it, but it's going to be perpendicular. So you're going to actually want to put the symbol for 90 degrees so that way you can indicate that those are perpendicular, because if not, we won't be able to tell the difference between an orthocenter and the different types that you could have. So make sure that you note that those are 90 degrees. And so that point P is called our orthocenter. Our next one is called the centroid, and that centroid happens whenever we draw a median on every side, right? So remember, the median goes from the vertex but to the midpoint of the other side. So when we draw that, we'll go from our vertex and we're going to draw to the median. So that means it's going to cut that segment in half. And then we'll do our next angle and we'll connect that angle to the midpoint, and then it cuts that segment in half. And then we'll go from our last angle, angle Q, and we'll connect it to the midpoint of our other segment, and it cuts that in half. So whenever you are drawing these medians, it's very important to make the marks to show that you have split that in half and that those are congruent sides. That's how you show that you have drawn a median. And this point that we get whenever we draw the three medians, that's our centroid. Okay, so let's fill in the blank. Let's see if you remember the differences between these, because that is what you're going to have to know. Like, you're going to have to know inside and out what is the difference between an orthocenter, a centroid, an incenter, and a circumcenter. You're going to have to know their differences, and you're going to have to be able to draw all four of them. Like, you're going to have to know how to draw them, how to illustrate them. And so let's review these. An angle bisectors are concurrent at the blank. So the orthocenter and centroid are connecting the vertex to the opposite side. So you know that this is not the orthocenter or the centroid. And so it's either going to be the incenter or the circumcenter. So the circumcenter was the one where we had segment bisectors. So incenter was the one with the angle bisectors. So this would be incenter. The angle bisectors are concurrent at the incenter. The altitudes are concurrent at the blank. So remember, the altitude connects the vertex to the other side with the perpendicular line. And remember, we said that was the orthocenter. Okay, and so here's a picture that's drawn, and we have to identify what's the point of concurrency here. Which one? Orthocenter, centroid, incenter, and circumcenter. So remember, these are all called points of concurrency. These are the 4 points of concurrency. So the question is, which point of concurrency is illustrated here? So it looks like we have, these are being divided, right? So this must be a midpoint because these two segments are congruent. Okay, so that means that that would be a centroid because we have 3 medians there. All right, go ahead and try some problems on your own.